So welcome friends. I am now going to describe to you how do we draw the network diagram using the activity on arrow convention. AOA stands for activity on arrow convention. So let me take you to a small problem and let us see how we are going to solve this particular problem. So first and foremost, what do I observe here is that I've got series of activities A, B, C, D, E, F, G, H, I, J. All the activities must be completed for the project to be completed. Now, some of the activities have got predecessors, like activity D cannot start before activity A has to be completed. Activity E and F cannot start before activity B gets completed. Whereas, if you look at activity A, B and C, there is no predecessor. Also, activity E and F will not be anyway related to the completion of activity A. Now, this is what is known as the predecessor relationship. The first step here is to draw a network diagram showing the predecessor relationships. At this point in time, do not focus on the duration, just focus on the relationship. Now, at times students ask me, how would we figure out whether there is a requirement of a dummy in the network? Now, don't be bothered with this question at the start. Start drawing the network with the first activity, the second activity and the third activity. As you keep on going ahead, you will therefore see a necessity for perhaps a dummy activity. But at the beginning, do not try to figure out how many dummies would be required in this particular problem. So let us see how do we construct the network for this problem using the activity on arrow convention. Repeat, look at the activities, look at the predecessor relationship. Now, before I start talking about activity on arrow convention and constructing the network diagram, let us understand what do we mean by activity on arrow. Now, whenever I say activity on arrow, every activity is shown like an arrow and the name of the activity is written on the top. But very important, every activity must have a start and every activity must have an end. Now the start and the end is called the node. So I would say for activity A, 1 is the start node, and for activity A, 2 is the end node, also called finish node. Now please note, every activity would be complete only when it has a start node and it has an end node. If you only have a start node or only an end node, then the activity is incomplete. That will not be acceptable. The name of the activity is written on top, and next we can write the duration of the activity. Now, there might be a scenario where I have a situation which is something like this. There are two activities having the same start and the same end. Now, the activity on arrow convention is very clear. You cannot show anything like this. In other words, activity on arrow tells you very clearly that no two or more than two activities can have the same start and the same finish. What am I saying? We could perhaps have a situation like this. Same start but different finish, or different start but same finish. So now this is possible, but two or more activities having the same start and the same end is just not possible. So how do I show this relationship? Simple. I'll say 1 to 2 is A, 1 to 3 is B, and then wherever B is ending, I can join a dotted line to 2. Now the dotted line is called dummy. Now the dummy activity does not require any resources, the dummy activity does not require any time, but what is important is the dummy activity shows a relationship. Now what was my requirement? That I cannot go beyond A and B to go for any other activity, but I could not show it as the first diagram. Therefore, in this convention, A has got a separate end, B has got a separate end, and this dummy activity serves the purpose of ensuring that we cannot go beyond this point without completing A and B. So, had you drawn something like this, for C it would have been wrong, and the correct way is to show it like this. So, this is what I said. Whenever we draw the network diagram, we are going to see that perhaps we now need to have a dummy. So, with this little introduction, let us go and see how we can construct the network diagram for this particular problem that we have seen. So, activity A, B, C, D, E, F, G, H, I, J. A, B, C has got no predecessors. D has got A, E, F goes B, and G has got C. Then H has got predecessor D and E. I has got predecessor F and G, and J has got predecessor H and I. So, we are going to start the network diagram, and as you know, activity A, B and C has got no predecessor, or in other words, we can start with activity A, we can start with activity B, and we can start with activity C. Now, I am not numbering the nodes. Why? Because once we have a final structure, then we can number the nodes. Next, D follows A, so wherever A is finished, I can start with D. E and F follow B, so wherever B is over, I can start with E, I can start with F. And G follows C, so wherever C is over, I can start with G. So far so good. This is how we are going to do it. Now, H depends on completion of D and E. What does it mean? It means that there should be one point where both D and E have finished, whereas here I am showing there are 2 points where we have got D and E finishing. So I'll make a small change. And what is the small change? Instead of showing E and F like this, I will show E and F like this. So this is E, this is F. Now to start with H, I need one place where D and E is completed. So this will be my H. And to start I, there should be one place where G and F is completed. So I would draw I like this, but then the next activity J requires H and I to finish at the same place. So I will construct I like this. And finally, I am going to talk about J. Now, this is how you are going to make a rough sketch, and once you make a rough sketch, you can then make a final sketch. Next, how do we number the nodes? The numbers are ascending order, left to right, top to bottom. I repeat, ascending order of numbers, left to right, top to bottom. So 1, 2, 3, 4, 5, 6, 7, 8. Now, this is your completed network. Now, what do you see here? You see here that we start at 1 and the project is going to end at 8. So, every project should have one start. So, I can call this as a start, and every project has to have one end. So, we are going to call it as end. Now, this is the requirement of the activity on arrow convention. Every project should have one start and one end. The arrow should go from left to right, ascending order of node numbers, and this is how we are going to construct your network. This was our network which we have constructed. So what I have done now, I also put in the duration of the activities adjacent to the activity title. Now, the first sketch is always a rough sketch. Subsequently, you are going to make a fair sketch. Now, before I go further, let me just ask you, if I have a situation like this, that besides these activities, there was also activity K which dependent on D. So please note, K depends only on D, and in this case, if I would have shown that completely wrong. Why? Although K depends on D, K does not depend on E. But what is my net? My network is showing here that K is also dependent on E, which is not correct. And therefore, what changes will I have to make here? The changes that I will have to make here are going to be as follows. So friends, what would be the changes made? It will be as follows. Now look at the diagram. Activity K depends only on D, yes. Activity H depends on completion of D and E. Now D is completed at 5, but the dotted line dummy is going to show that at 6, D has also completed. At 6, E has completed, so we can start with H. Now K is independent of E, K depends only on D, but there is one more criteria. The criteria is that every project should have one start and one end, and dummy at the beginning. But as you keep on constructing the network, you'll soon realize that you might require a dummy. What is the next step? The next step is we have got this network diagram. Then we have to do certain analysis. Analysis meaning forward pass calculations, backward pass calculations, calculation of the total float, which we will see in the next video.